My name is Madison Wood, and I'm a PhD candidate in Earth and Planetary Sciences at the University of California, Santa Cruz. I have a bachelor's degree in Earth Sciences from the University of New Hampshire, and as an undergrad, I spent a summer studying at the University of Exeter in the UK, where I ventured out into the peat bogs of Dartmoor National Park, extracted cores of sediment from the Earth, and learned all about the clues to carbon cycling that are recorded there. This is when I decided to become a carbon cycle detective. My research uses geochemical tools to reconstruct what the carbon cycle was doing in the past, so we can study links between carbon and the climate. I'm really interested in one important component of the carbon cycle, marine carbonate burial. Many critters that live in the ocean form calcium carbonate shells and skeletons. When they die, the carbonate falls down to the seafloor, and some of it is preserved and sequestered in the sediments. Over long time periods, this process removes carbon from the ocean and the atmosphere. We know that carbonate burial is linked to how much carbon is in the atmosphere, so you can imagine changes in carbonate burial could have an impact on the climate. I want to document what those changes may have been, kind of like a carbonate burial historian. Like any historian, I need a reliable archive. In my research, that's ocean sediments. Sediments build up on the seafloor over thousands of years, like layers in a layer cake. The minerals in each layer reflect the chemistry of the ocean at the time those sediments were forming. So we can go drill into the ocean floor and bring up a sediment core that gives us a record of ocean chemistry through time. My work focuses on one mineral called marine barite, which records stable strontium isotopes, a proxy for how much carbonate was being buried in the ocean. By measuring strontium isotopes in ancient barite, I can reconstruct how the isotopes of strontium in the ocean changed over time. And from this proxy, I can infer how carbonate burial changed. The period I'm currently focusing on is the Quaternary, which covers the last 2.6 million years, and is an interesting time because the climate was undergoing cycles between cold glacial periods and warm interglacial periods. Atmospheric carbon dioxide was also increasing and decreasing over these cycles. My goal is to figure out how carbonate burial changed, so we can assess whether it contributed to changes in carbon dioxide and climate. This is an open question in my field, and it's an important one because it tells us about the strength of feedbacks between the climate and carbonate burial in the ocean. I'm so grateful to ARCS for supporting this research, and I'm really excited to be part of the ARCS community. Thanks for listening.